Good day, everyone. I am John Brian Almazan, presenting to you the radiation and propagation of waves. The wave propagation refers to the traveling of waves with respect to the direction of the oscillation relative to the propagation direction. Longitudinal waves can be distinguished from transverse waves. Electromagnetic waves propagate in a vacuum or free space as well as in other material medium, while other waves cannot and need a transmission medium to exist. The wave radiation refers to the emission of energy. In physics, radiation is the transmission of energy in the form of waves or particles through space or through a material medium. This includes electromagnetic radiation such as radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma radiation. According to a research that was published by IEEE, Hertz in 1880s demonstrated electromagnetic wave propagation predicted by Maxwell from his equation in 1864. Heaviside and Kennelly postulated the ionosphere to explain Marconi's historical transatlantic reception of radio waves in 1901. Austin derived the first formula for radio propagation in 1911 from experimental data in the kilometer wavelength range. Free space usually refers to a perfect vacuum. In electromagnetism, it refers to a reference state which is sometimes called classical vacuum. In quantum physics, it is referred to the ground state of the electromagnetic field. Isotropic model. From the word isotropic, it means material having identical value of a property in all directions. Polarization. It is the attribute that wave oscillations have a definite direction relative to the direction of propagation of the wave. The direction of polarization is defined to be the direction parallel to the electric field of the electromagnetic wave. This section discusses the optical properties of radio wave, namely reflection, refraction, and diffraction. First is the radio wave reflection. It is when the wave encounters a change in medium. Some or all of it propagates into the new medium or be reflected from it. The part that enters the new medium is called the transmitted portion, and the other one is the reflected portion. The angle of incidence is the angle between the direction of propagation and a line perpendicular to the boundary, while the angle of reflection is the angle between the direction of propagation of the reflected wave and the line. The two pictures from the right illustrates how a wave reflects a certain boundary. Second is the radio wave refraction. It is when the wave enters a new medium. When it does, the speed of propagation will change. In order to match the incident and the transmitted wave at the boundary, the transmitted wave will change its direction of propagation. When the direction of propagation changes, the wave is said to refract. The transmitted wave will bend more towards the perpendicular when entering a medium with higher index of refraction. The given picture illustrates the refraction of the wave. The third one is the radio wave diffraction. It is when the wave passes through an opening, which is called an aperture. The wave diffracts. The degree to which the cropped wave will spread out depends on the size of the aperture relative to the wavelength. In some cases where the aperture is very large compared to the wavelength, the wave will see no effect, thus it will not diffract at all. Meanwhile, considering a very small aperture, the wave will behave as if it were at its origin and will spread out uniformly in all directions from the aperture. So in this section, I will be discussing radio wave propagation modes, and they are categorized into three, namely the line of sight propagation, ground wave propagation, and sky wave propagation. The line of sight propagation. This mode is the most common of propagating radio waves. As the name implies, the wave travels a minimum distance of sight, which means that it travels to the distance up to which a naked eye could see. An amplifier is then employed that is combined with a transmitter to amplify the signal for further range of wave propagation. The line of sight propagation will not be smooth if there happens to be an obstacle in its transmission path. So this picture illustrates the line of sight propagation of waves. Ground wave propagation. The signal exists in proximity to the Earth's surface. Thus, it follows the contour of the Earth, and it can propagate considerable distances. That wave is called direct wave. Waves that are propagated sometimes bends due to the Earth's magnetic field and gets reflected to the receiver. That wave is called reflected wave. The upper picture illustrates the transmission of the signal as represented by the direct wave and the reflected wave. The wave that propagates through the Earth's atmosphere is known as a ground wave. The direct and reflected wave both contribute the signal at the receiver station, and once the signal reaches the receiver, the lags are cancelled out. The signal is filtered to avoid distortion and amplified for clear output. Skywave propagation. It exists in the sky and depends on the reflective characteristics of the ionosphere layer. The signal is reflected from the ionized layer of the atmosphere. With this propagation mode, the signal can travel number of hops back and forth. During the right time, ionosphere is closer to the Earth's surface. By that, it will travel at a flatter angle, thus traveling larger distances will have more skip zones, which will result into no reception. During daytime, ionosphere is away from the surface of the Earth. Thus, signal travels at a certain angle and traveling at smaller distances. So these are the references that was used in this discussion. So that concludes my presentation. Once again, I'm John Brian Almazan. Thank you.